Hello students, Ms. Slyman here with our next graphing example. So let's start by thinking about our vertical asymptotes. Those are always the easiest. So here we're going to have a vertical asymptote whenever x squared minus 4 is equal to 0. Well, that's the same as x plus 2, x minus 2. So x equals 2 or negative 2. Those are my x-intercepts, or sorry, my vertical asymptotes, not x-intercepts. Vertical asymptotes. Horizontal asymptotes, I don't have one. Power of numerator is 1 bigger than denominator. That tells me I'm going to have a slant asymptote. So let's think about that slant asymptote. Really, my denominator is x plus 2x minus 2. So I might want to use synthetic division and try using one of those. So if I try negative 2, I've got 1x cubed, 0x squared, 0x minus 1. Draw the line, 1, negative 2, positive 4, 4, negative 8, negative 9. If I use my synthetic division and get a remainder, then I can't use synthetic division again. And since I need to have x cubed divided by this whole thing, synthetic division does not work, and I need to go back to long division. So let's do our long division. We've got x squared minus 4 dividing into x cubed plus 0x squared, 0x minus 1, x squared times x equals x cubed minus 4x, lining everything up. Draw the line, change the signs. 4x. X squared times nothing will give me 4x. So that means that my function of y has turned into x plus 4x over x squared minus 4. My slant asymptote then, this is my end behavior because as x goes towards infinity, this is going to become 0 because I'll have infinity divided by infinity squared. So my behavior is just going to look like x towards the ends. So let's draw that in. Let me think about a slope of 1 is going to look like this. So drawing in my slant asymptote. Of course, you're going to have rulers to make it easier. So there's my slant asymptote. Let's think about intercepts now. When x is 0, the y value is going to be 1/4. So when we've got 0, we've got positive 1/4. When y is equal to 0, that is going to be when x cubed minus 1 is equal to 0. That happens when x is equal to 1. With a cubic, this really means I've got 1 repeated 3 times. It's not like a quadratic where we get a positive and a negative. 1 cubed is equal to 1, negative 1 cubed is negative 1, so that's only one answer here. So we've got 1, 0 as our x-intercept. 1/4 for the y-intercept is really hard to draw on this scale. And now let's think about a sign chart for making our graph here. So again, sign chart is just telling us positive, negative y behavior. So thinking about my sign chart, I'm going to make an x-axis with my key x values. So negative 2, 1, and positive 2. If I think about to the left here around negative 3, negative 5, what have you. So negative 3 cubed would give us negative 27, that's negative 28 on top. Negative 3 cubed is 9, so 9 minus 4 is a positive number. Negative divided by positive is negative. So over in this region, all of my y values are going to be negative. So for any x less than 2, my y values are negative. That tells me that I'm going to follow my asymptotes down in quadrant 3 where all my y values are negative. between -2 and 1 is 0. We already know at 0 that the y value is positive 1/4. So from -2 to 1, all of my y values are going to be positive. So I'm going to switch over to black. So I'm going to have positive y values up until 1. And now we want to know, are we going to flip back up or are we going to continue down? So from 1 to 2, that's a value like 1.5 or 3/2. So let's go ahead and use our calculator to help us here. So I'm going to make a fraction. And I've got 1.5 cubed. And then we are subtracting 1 divided by 1.5 squared and subtracting 4. And what I care about with my answer is it positive or negative? And it's negative. So that tells me in this region, I get negative values, so I must be coming down. And I assume that over here I'm going to get positive values. So coming up, we could just come up and replace all of our 1.5s instead with 2.5s. That's going to be the easiest to replace. Oops. 2.5 and then 2.5, and I can just hit enter from in the middle there. And now I get a positive value of 6.5, which tells me that all my y values from 2 until infinity are going to be positive. So I'm going to follow my graph, follow my asymptotes where the y's are positive. And there is our graph for x cubed minus 1 over x squared minus 4. And again, I could check that with my technology. Let's go down and clear this one out. Up top, we had x cubed minus 1 over x squared minus 4. And let's look at the graph. And we've got the same graph that we drew. If we wanted to see our asymptotes on this as well, to see if we really are following it, we could go in and add in y equals x, just to see that we are tracing along our asymptotes. And sure enough, it looks like we are. I will see you in class.